So this is a video about the calculations behind the ANOVA. We're starting out with our data, which is here people, person 1, 2, 3, right, until 20. So there's 20 people in groups, in 4 different groups, group 1, group 2, group 3, group 4. And then, ironically enough, a stats quiz score for each person. So person 1 in group 1 had 14 points. Person 2, also in group 1, had 15 points. And so forth. And then person 6 was actually in group 2. She had 14 points. And this person number 7, group 2, had 13 points. Then person 11, group 3, 11 points, and so forth. Right? Now what we're trying to do is to figure out the variation within each group, right? So you know how to calculate variances. That is exactly what we're going to do right now. For group 1, we're figuring out the average. So 14, 15, 13, 13, 14. The average of this group is 13.8. So each member of this group gets this score, 13.8. For group 2 down here, the average is 13.2. So each member of this group gets 13.2. Group 3, the average is 11.2. They all get 11.2. Group 4, the average is 14.6. They all get the score 14.6. Now what we want to do is how much within each group do these people vary around this mean, right? We want to know, are these people pretty similar in each group, or are they very different? So 14 minus 13.8 is 0.2. So this person with 14 points is 0.2 points above average. Next person, 15 points, minus 15 minus 13.8, 1.2. So this person is 1.2 points above average, right? We continue. This person has 13 points, minus 13.8 is negative 0.8. So this person is actually 0.8 below the average. Okay. Now we get another person right here. The last one, 14 minus 13.8 is 0.2 above the average. Okay, so this is the differences to the mean for group 1. Now if we want to summarize that, if we would want to summarize that, right, we could add this up. But remember, we have the problem that we have positive and negative values, and since they're all distributed around the mean, if we add this up, we'd end up with 0, right? 0.2 plus 1.2 is 1.4, plus 0.2 is 1.6, and then minus 0.08 is 0.8, minus 0.8, and we're back to 0. Okay, so that's why we're doing this squared, right? We're squaring these scores. So 0.2 times 0.2 is 0.04. So we have all these values squared. And now we do the same thing for group 2 down here. And then we do the same thing for group 3, and then the same thing for group 4. And now what we do for the ANOVA is we're adding all these up together. Remember, we did the same thing to calculate the variance, but we're going to hold off for a little bit. We're just going to add these up, the sum of squares. And then what we're actually doing is, down here we have our ANOVA table. We're looking at within groups, sum of squares. That's where we enter our 23.6. Okay? This is the one thing. Now, the other one is we're going to go a step further. Now we want to know, right? We need two values. We need a variation within the groups, and we need a variation between the groups. So now we're trying to figure out how much the groups vary from each other. So we're basically doing the same thing that we did before for each group. We're doing now for all the groups. So if you imagine now group 1 here gets the average for group 1. 13.8. All the people in group 1 get 13.8. For the grand mean, the grand mean is the overall mean. That's why they call it the grand, because it's so grand, right? The overall average is 13.8, 13.2. All the people get 13.2, right? So 13.2 is the average of the stats quiz score. So now what we do is for each group, you get the variation that they're away from the average. So you see 13.8 minus 13.2, 0.6. So the group 1 is a little bit above average. Group 2 is exactly average, right? Zero difference. Group 3, 11.2, is a little bit lower. And group 4 is quite a bit higher, 1.4. Okay? Now we do the same thing because if we would add these up, we'd end up with 0, right? 0.6 plus 1.4 is 2, minus 2 is 0, and 0 all evens out. So here, again, we do the same thing. We square these distances, and then we add them up. This gives you your sum of squares between. And as you could imagine, right, we're doing the same thing a lot of times, right? You could really just do this once for group 1, and then times the people in this group. You could do it for group 2 once, and then times 5, for example, for this group, right? You could do it shorthand, but here is really, you get it all detailed how it works out for each person. So then again, we transfer this number, sum of squares between, to our ANOVA table. So that this number comes down here, between groups 31.6. So between groups 31.6, within groups 23.6, and now just by the pure math, the total variation is 55.2. It's between groups plus within groups. Okay, that gives you total variation. Now, because I know you're very critical thinkers, we're just going to calculate the squares total really quick, just to show that if we calculate, we get actually 55.2 as well. How do we get the total squares variation? That's by taking the individual scores, right, for each person, 14 points for person 1, 15 points for person 2, and then we use the grand mean as our average, right? So for the overall variation, the total variation, we want to know, hey, how much do people vary around that big mean? How much do they vary around the average? And then we do the same thing that we just did with the within groups and between groups. All right, we calculate the difference. So the first person is a little bit above, 0.8 points above. Second person with 15 is 1.8 points above 13.8, and so forth. And then we square these distances, and then we add them all up, we get a total of 55.2. And now you have the first key component of your ANOVA table, the between groups and within groups. All right. And actually, you could already try to compare between group variation with within group variation, right? That's what we're shooting for. However, right now we just have the sum of squares. We don't really have a measure of variation yet. It's the same thing that we did for calculating the variance, right? We calculated the sum of square differences, and then we divided by n minus 1, right, to get that variance. So we're doing the same thing here. We're taking the sum of squares for the between group, and then we have the n minus 1, the degrees of freedom. It's just 4, right? We have 4 groups, minus 1 is 3. So 31.6 divided by 3 is a mean squares for the group of 10.53. We're doing the same thing for the within group. We have a sum of squares of 23.6. The degrees of freedom here we get by taking each group minus 1. So 5 minus 1 is 4, 5 minus 1 is 4, 5 minus 1 is 4, 5 minus 1 is 4. So 4 times 4 is 16. Right? Or you could also do the total number of people minus the number of groups. So we have 23.6 divided by 16 is 1.475. All right. So now to get our F ratio, right, we're comparing between group variation with within group variation. In this case here, our estimate for random or natural variation is 1.475. Right? If there were no difference between the group, the between group variation would have to be around 1.475. So we're comparing this ratio, right? Now we see 10.5 and 1.5, roughly 7 times bigger, right? The between group variation is roughly 7 times bigger than with the within group variation. So that's a pretty big F value here. And now we calculate the probability of this F value, and actually Excel can do that for you. It can, right? It can pick the proper graph, the proper curve, right? Those curves that we have been talking about. It figures out what's the degrees of freedom between the groups, what's your degrees of freedom within the group, picks out the right curve, and tells you your probability in when you have 4 groups and 5 people in each group, your probability is 0.0029 to get an F value of 7, if there actually is no difference. If there were no difference, so there's a really small chance right now that we get this big of a number if there actually is no difference in reality, right? So this number here, way smaller than 0.05, we say this is a statistically significant result. We reject our null. We assume there is a significant difference somewhere here between those groups. Okay, this is how the ANOVA is calculated, the one-way ANOVA is calculated in detail.